Hello everyone. Okay, let's have a quick go at this question. Pause it if you want to have a go first. Right, the discrete random variable x takes values 1, 2, 3, 4, 5. Probability is defined as follows, where a is a constant, show that a equals 16 over 31. Okay, the first thing is, let's draw the table out. Okay, so I'm just going to quickly see if I can squeeze it here. What I'm going to do is, if I put x is 1, so if we put table here, x, and then you've got the probability large x is equal to x. Move it along, this is part of the working out, so you've got to get something like as we're going through it. So what happens here is, first of all, if you put the x is 1, that will be a. Okay. Now when x is 2, that's going to be 2 take away 1 is 1. What was the probability of x equal to 1 was a, so it's going to be half that, so that's going to be half a. When x is 3, 3 take away 1 is 2. The probability of when x plus 2 was half a, so we're going to half it further, so that's going to give me 1/4 a. And x is 4. Again, 4 take away 1 is 3. Probability when x was 3 is 1/4, half that is 1/8 of a. And then last one, 5. 5 take away 1 is 4. Probability of x is 4 is 1/8 of a, so we're going to half that further, it's going to equal 16 of a. Now, that's your probability distribution at the moment. In terms of a, what we do know that the sum of probabilities, I'll start writing here now, we know that the sum of probabilities, the sum of probabilities x equal that is going to equal to 1. So we know that a add half a plus 1/4 a plus 1/8 a plus 1/16 a is going to equal to 1. So we could put them all over 16, so that's going to give me 16a plus 8a plus 4a plus 2a plus 1a all over 16 would equal 1. So times that over and at the top, so we're going to get 20, 31, so you end up with 31. A equals to 16, so therefore a equals 16 over 31. So we've got that one done. Next one, part 2, find the probability of an odd when x is odd. So when x is odd, that's an odd, that's an odd, and that's an odd. So it's just literally, so by the way, when you got this, you multiply this out, you will get these probabilities. Okay, if you put it through there, you'll get those. So half the 16 gives you 8, 1/4 of 16 gives you 4 over 31, 1/8. 16 divided by 8 is 2, so there's 2 31s and 1 over 30. Okay, so that's where those numbers are coming from when a is there. Right, so what is the probability of an odd? It's going to be 16. I'm going to put them all over 31 plus 4 plus 1. It's going to give me 21 over 31. So that is the probability of getting a odd number. Okay, right, so done. Next one. 2 independent, now very important, independent means that we can just times probabilities when we're working them out. So 2 independent values of x are chosen and the sum is found. Find the probability that the sum is odd. Now if you add 2 numbers, you should know that, I'm going to write them all out so you know that add an odd number will give me even. An even add an odd is going to give me odd. An odd add an even is going to give me odd. So, and the even will equal even. So we just want this selection and this selection, where one number is even followed by an odd, or an odd followed by even. So when it goes find the probability of getting an odd number, just quickly do part. So we've done that one. We know what the probability of getting an odd number is. So just going to do part 2. So I know the probability of getting an odd number is going to be 21 over 31. So the probability of getting an even, there's only odd or even, so take 1 from there, so you're left with 10 over 31. So therefore, the probability of getting an odd and an even, and the independent, which means we can just do 21 over 31 times 10 over 31. And also vice versa, if we do even and odd, so we can have them the other way around. So we've got 2 of those selections, so I'm going to double it rather than doing too much working out. So if you multiply those out, you should get 400, and so just quickly check that on your calculator, you should get 420 over 961. I'm just going to check that again, just to make sure we've got it all sorted. So, just 1 second. What did we say? 21 over 31 multiplied by 10 over 31 multiplied by 2. Yep, it's that. And if you want it as a decimal number to 3 single figures, that would be 0.437. Okay, so that is the probability of getting an odd number. Find the probability that S is odd. It's done that. So you can write probability S equals odd, which is 0.437. Done. Okay. Find the probability that S is greater than 8 given S is odd. So let's just do 4 here. I'm just going to use a different color so we can, so we're not getting confused with this here. So now I'm going to rewrite this. So find the probability S is greater than 8 given S is odd. So probability S greater than 8 given S is odd. Okay, so that is the same as probability S is greater than 8 and S is odd divided by probability S is odd. Okay, so we already worked out S is odd, so I'm just going to quickly put 0.437 here. So we need to now work out probability that S is odd and it's greater than 8. So how can we do that? So we can have I'm just going to quickly write down. So first of all, if we get, let's start with the largest number. We can have a 5 and a 4. Okay, so that will give me odd and it's greater than 8. We can have obviously a 4 and a 5, so we've got 2 of those. What else can we have? Can we have a no, that's the only option we can have actually. We can only have a 5 and a 4, which will make 9. Kind of a 5 and a 5, but that would be 10, but it would be even. You can't have a 4 and a 3. Anything 4 and 4 is 8, so you can't have that. It's going to be greater than 8. 4 and 3, anything less than that will be. So that's the only one, and once we worked out that, we've got to times it by 2 because you can get a 5 and a 4 or a 4 and a 5. So let's just work that out. So probability S is greater than 8 and S is odd is equal to, so we can select a 4, which is 2 out of 31, and then select a 5, which is 1 out of 31. And there's two ways you can do that, because you can select a well, you can select a 4 and a 5 and a 5 and a 4, so there's two ways of doing that. And that will give me, if you multiply those out, you will get 1 over 105, which if you use a calculator, I'm just going to double check that again, 2 over 31, always double check what you're doing and what you're putting into calculator is correct. One of my weakest points sometimes. Multiplied by 2. Oh. Yeah, that is not equal to that. Can I just rub that out? Because I jump straight to the answer. So that is going to be, actually, that will be 4 over 961, which is equal to, decimal place, 0.0416. So put that over here, 0.0416. If you work that out, that divided by 0.437, you're gonna get an answer of 0.00952. So I'm going to write that out again here. And that's going to be, so probability, so the answer to this is going to be, I'll write it here, I'm running out of space, it's going to be 0.00952. Okay, yeah, yeah, I'm just going to confirm, just double check that again, making sure we get that. Yeah, that's what I get. Okay. Okay. Right, so that's done. So there's the answer. 0.0. Right, there it is. I'm just going to write it out here clearly so it's next to it. 0.00952. So that's what that is. Right, so we've done that one. Done. Right, 2 more marks to achieve. Right, so here it goes, Sheila sometimes needs several attempts to start a car. In the morning, she models the car with a discrete random variable y, which follows this distribution. For all positive values of y, find when y equals 1. Right, let's do a table here. So what we got is we got y. Okay, so this is part 5. I'm going to draw a table, and this is probability y equals 1. Right, so y can be 1, 2, 3, 4. It just keeps on going on. I mean, we can have many attempts of trying to keep on going. So let's just start this off. So first, we don't know what it is, so we can just call it, the first one is x. So the second attempt to start the car, the second attempt is half that, so it's a half chance of, so remember that this is a probability of the previous term. So if we just label that x, okay, the second attempt will be half the probability of the first attempt, so that's going to be half that. And then it just keeps on halving. That'll be a quarter of x. That will be 1/8 of x. Just like we were seeing, actually, it's looking very similar to what we got here. It's very similar. The only difference here is this continues to go, 16 of x. So they are trying to link it up to this question. This is exactly what's going on here. 16, 1 over 32. x, and as these numbers go, this will carry on. So this kind of makes up like a convergent sequence. So it looks like an infinite sequence that's going on. Okay, and for infinite sequences here, what we can use is our geometric series formula. So if we want to know, well, the formula is the sum to infinity is going to be 1, is a over 1 minus r. So you should be familiar with the sum to infinity. Now we know that the sum to infinity, if we add all the probability adds up to 1. So we know that this is going to equal to 1. So the initial term is x. The ratio here, you times in each time by a half. Okay. So that's the common ratio. So 1 take away half is just going to give me a half. And that's going to equal to 1, because the sum of infinity, sum of this probability is equal to 1. Now if I, because this is being divided by a half, so I can just times the half to the top, so therefore x would equal just a half. And that is our first sum. So probability y is 1 is x, which we know now is half, so this will be half. Okay, so that's done. So they have tried to link this scenario to a similar thing what we hear. And then it goes here, give a reason why one of the variables x and y might be more appropriate as a model for the number of attempts Sheila needs to start her car. Well, me personally, I would go for y. You could argue both ways. You could say that this only goes up to 5, so you can try to start your car again. But you could also argue, which I would argue, that after a number of attempts, the battery will be flooded and the car will go flat, so it won't start. So, and give a reason as long as you back it up. So give a reason, one of the variables. So I'm going for y, and my reason is y is more appropriate because you only have a limited attempts to start car before battery is flooded. Okay.